In this lecture, we'll discuss some of the fundamental issues of artificial intelligence. What is intelligence? How we can define artificial intelligence? Where artificial intelligence is going in the future? I'm Arthur Kordon, a board member of ORCHESTRATE AI and a practitioner with applying artificial intelligence in industry. My experience is longer than 30 years, and what I'll give you in this lecture is a common sense view from a practical point of view. What kind of topics I'll cover? First, we have to discuss this issue of defining biological intelligence, and especially human intelligence. Based on this definition, based on this insight, we'll move to discussing the artificial intelligence issue. And because one of the key issue in the current development of AI is the extremely high dynamics of development, we'll partially cover this topic as well. I call this phenomenon AI Big Bang. And at the end, we'll discuss the hot topic of where is going AI. But let's begin with the animal intelligence. I cannot convince you. I don't need to spend much efforts to convince you that some of the animals are really intelligent. Here I give you very common and well-spread cases with smart animals like octopuses. To me, very appealing of showing the smart nature of the chimpanzees is their capability to use tools. For example, how to extract termites with thin sticks shown in the middle of this slide. And there are numerous cases of pets, especially smart dogs. What is also interesting from biology and from exploring the evolution is that a common denominator in the evolution of the species, of the biological species, is also the evolution of the brain. It turns out that the brain is the key carrier, biological carrier of intelligence. It is different in sizes, and here I'm showing the comparison of the sizes of different biological species with the human brain. But what is important and what is the fact that we need to pay attention is that at the basis of the brain, the basic cell in the brains of the biological species are neurons. What you'll see later is neurons and neural nets are one of the key technologies of artificial intelligence as well. What is also very important, if we focus on the most important for us biological species, the humans, we can see one very important detail, that the sizes, the power of the human brain had evolved tremendously, especially in the last 2 million years. And there is an inflection point around 2 million years when the size of the human brain had more than doubled. And what is interesting is that this corresponds to two events. Above all, the humans moved to social type of life and using language, number one. And number two, they begin using tools for survival. And they very soon became the leader of the biological world. And here is shown some of the tools in the different cultures and corresponding the complexity, the evolution of the complexity of the tools with the sizes of the brain. What we could what we could generalize is that at the end, the human brain is the carrier of human intelligence, of the biological intelligence, number one, and the very important fact, which will be of crucial importance, how we'll see, for the future development of AI, is the structure of the human brain, that the human brain is very well structured. And the more we explore it, the more details in the brain structure we learn. And even recently, we move to the next step. After understanding the features of the brain, we begin to control the brain. And these are the first steps of the company Neuralink. And to my knowledge, recently, and this lecture is recorded in July 2025, 7 humans are using the chips of Neuralink, in fact, to control the brain and to compensate the damages of some of the structures of the brain with the power of the chips. And I think this is the direction which we need to explore more in the future. At the end of this section, we need to have make an attempt to define what do we mean by human intelligence. And here we'll face the same feature as any definition related to intelligence, AI, and the new phases of AI. We have too many definitions. There is no clear unification to say, okay, that's it. And here I give, from the many definitions, I selected several. I personally like the yellow one, that intelligence is what you use when you don't know what to do. It's opposite to the common opinion that links intelligence to the volume of knowledge. My personal opinion is that it's exactly the opposite. We need, above all, intelligence when we don't have the clear rules of a lot of knowledge what to do. We have to be inventive what we don't know what to do. And to me, that's intelligence. There are a lot of theories of intelligence. Again, I'll not talk too much about them. But one of the prevailing theories is Gardner's theory of 8 multiple intelligences. Gardner claims that there is no one universal intelligence. Intelligence is specific to different activities. And that's why he defines 8 multiple intelligences: logical, naturalist, body kinesthetic, musical, rhythmic, interpersonal, intrapersonal, visual, verbal. And here is one of the questions I have, especially for the future direction of so-called general artificial intelligence. In this separation of 8 multiple intelligences, which Gardner built his theory, we have, let's look at 2 clear cases. Let's focus on the logical, mathematical intelligence. We have a very clear example of a genius in this category, Einstein. He was on the top of this type of intelligence. At the same time, however, he has musical intelligence. A lot of people claim that he played violin not bad. He was not the top professional, but he played it really good. He was riding a bike. He was not so good at that, his colleague in Princeton said. But the question I have is how we can define Einstein's intelligence. 150% logical, 80% musical, and maybe 5% bodily kinesthetic intelligence. And the next question, how we compare Einstein with Mozart? Mozart is obviously on top of the musical intelligence. Can we compare both at all? Can we also compare Einstein with Niels Bohr, another genius in quantum mechanics, in the logical, mathematical? Can we say Einstein has 120 logical intelligence and Bohr has 118? Nevertheless, that Einstein is the genius of general theory of relativity, Bohr is the genius of quantum mechanics. So, as you can see, there are a lot of fundamental issues, even at the basic level of the first basic topic we discussed, what we mean by human intelligence. Let's go now the next step and to focus on the next type of issues related to artificial intelligence. And the topic that we'll discuss here is first to very clearly to define the 2 key types of artificial intelligence, basic and generative. Even to discuss shortly the new wave of agentic AI, which, when we think more carefully, are a mixture of the both types. They are not well defined. It's too early to define them as a new type, but we'll look shortly at this type of artificial intelligence, and we'll do some comparison. Let's begin with some definition of the basic AI. It was also very difficult to find a definition. Even frankly speaking, I couldn't find one until IBM gave their definition in November 2024. What I like in IBM's definition is that for the first time, it defined AI as a technology, number one. Number two, this technology enables computers and machines. Uh, Usually the previous definitions focus only on computers. Here is much broader. It includes machines. It could be any type of machine. What is important is that the brain, the carrier of artificial intelligence, is a silicon chip. That's what matters. And this silicon brain simulates humans in several capabilities, above all in learning, comprehension, problem solving, decision making, creativity, and autonomy. I'm still not 100% sure that autonomy is a very clear feature, but we're going in this direction. This is the definition, a new definition, which to me is closer to AI capabilities in 2025. How we can define an AI system? And here also I would like to make the comment and the difference between ChatGPT, with which probably most of you are familiar, and the real artificial intelligence, or I call it basic artificial intelligence. Basic artificial intelligence must have this functionality or capabilities. It has to learn. It has to have the option of prediction. And based on learning and prediction, it has to reason. All of these three capabilities usually are used to solve complex problems. This short list recently becomes longer with capabilities to plan, to do some planning based on the reasoning, and to take actions. But for now, this is the minimum set of functionality that an AI system should have. How this could be done? These are not easy features to be accomplished. And behind the scene are several methods. Two of them, neural networks and deep neural networks, are based on mimicking the brain. We began first with very simple structures, but it turns out that we cannot do too much. We need much more complex structure to analyze images or to analyze speech or natural language. That's how the big breakthrough of artificial intelligence had been done in 2012 with deep learning, with deep neural networks. However, this dominant area, this dominant type of methods of basic AI are also complemented with several other methods. I'll not discuss them in details. Probably we'll have some lectures about them. But there are methods that can make automatic decisions based on data called decision trees. There are methods that use simulated evolution to develop very, very important solutions automatically. There are methods that are using some of the intelligence of animals, of ants, and a flock of fish to give us better option to optimize. And recently, as we'll talk shortly in a couple of slides, there is a growing field of intelligent agents. As we can see, a lot of methods that delivers this key functionality of learning, prediction, and reasoning, which are typical for basic AI. In November 2022, however, a new type of artificial intelligence appeared called generative artificial intelligence. The popular name is ChatGPT because that was the product that allowed almost anybody to communicate with this form of artificial intelligence by natural language. And what is typical for generative AI, or Gen AI as we call it shortly, is that it can create original content in a various type of forms, such as text, images, video, audio, or software code. Usually you ask a question or you ask a prompt, as is the specific terminology for Gen AI, and it can answer in these different forms. What is important to know is that, in fact, Gen AI models are based on compressed internet. The generic idea is very, very simple. We have a bunch of knowledge. We have the universal knowledge, the world knowledge, spread across millions of sites in the internet. Let's take it, compress it, and try to explore how much more intelligence we can get from this compressed type of knowledge. So what we have is, in a very big neural net, deep neural net model, we have all the universal world knowledge. Before we have Wikipedia, we have, even before, Encyclopedia Britannica. Now it is condensed everything with a lot of details, much more details than in Wikipedia, in the so-called large language models. And the large language model is a giant, deep neural net with 100 layers and billions. Even some of the biggest models have more than 1 trillion parameters. How it is organized? The idea is simple. The realization of this idea is not so simple and very expensive. It costs, in some of the most powerful models, more than $100 million. It takes weeks. But what it does is it extracts the textual knowledge spread across the internet. It optimized its content, its condensed contents in its trillion parameters. And then when you ask any prompt, it tries to fit the content of each word in the prompt with the knowledge, with the condensed knowledge in the large language models, in the deep neural nets. And it predicts word by word, word after word, the most probable sequence of words. This is the only thing that a large language model is doing. Surprisingly, this relatively simple algorithm works in most of the cases very well. That's why close to 1 billion people are using it. That's why it opens the door to many potential business applications. That's why everywhere, all students in the world love it, because it can generate their homework. That's why a lot of teachers hate it, because they're not so sure that this homework is written by the kids, by the students, or by the computer. And on the one hand, it creates a lot of opportunities, which we'll discuss all the time, and it creates a lot of problems. But what is important is that it made AI a mass-scale event. It had opened the door of AI to everybody, practically. Even more, recently, this unimodal, purely textual models, Gen AI models, now are open to more dimensions. I mean, now you could expect that you can generate images, music, voice, even video. So very short, it will be a standard multimedia type of Gen AI. And what happens is, especially in the last year and a half, a very important evolution of AI, when instead of being centralized in a computer or in a one big center, it become decentralized by the so-called AI agents. You can create small software entities that can do and define some actions expected from them and let them go everywhere in the web and do it for you. You may say, why AI has not done it before? It's really very exciting. The problem before was that these agents needed a brain. There were attempts 25 years ago to build agents by rules defined by humans, but it's very brittle. It didn't work. Wow. Now, the simple idea is, let's use LLM, let's use the large language models as the brain of the agents. And this fit between the hypothesis of an agent with their brain as OOM drove the technology, in fact, pushed the technology significantly, and now is the fast-growing branch of artificial intelligence. And here I give a very simple example, which is a very realistic example, by the way. We can begin with an agent, for example, an agent to control your oven in your kitchen, and then you can move to a so-called agentic AI, which is the key buzzword in the last couple of months, when you use 4 different agents to control your kitchen, everything in your kitchen. And that's where there is a very high chance that the business world is going. So we begin with the basic AI, which can do this 4 key functionality of learning, predicting, reasoning, and solving real-time problems. And we have the new Gen AI that pushed the idea of the very powerful option of agentic AI. But let's make it very clear about some comparison between basic AI or AI and generative AI. Because I want to make it very, very clear that, and here the left part of the slide shows it very, very visually clear, that Gen AI is based on deep learning, which are based on machine learning, which are part of the big picture of AI. And also to remind you that AI, the big picture, includes a lot of methods in order to apply all the power of AI, not the limited power of Gen AI, which is more limited to text, not to actionable type of items. We need knowledge, deep knowledge on machine learning, on data science, on at least some of these methods which are in the right part, which are shown in the right part of the slide. Basic AI is a deep technology. Gen AI is a popular technology which everybody can use, but it doesn't require the depth, but it has much more limited capabilities than basic AI. That's what I think you need to remember at this point. The third topic I'll discuss in this lecture, and this is a fundamental issue of AI, is the high dynamics of the field. Because this high dynamics doesn't allow us to teach it well, to understand it well, and to implement it effectively. Whatever we preach today will be obsolete a year from now. That's why it's very difficult. Also, I would like to emphasize on the fact that this explosion, which I call it Big Bang, is on 3 levels. And it has different dynamics on these 3 levels. And it has different consequences dealing with at these different levels. First, AI began as a theoretical, as a research, even as R&D. And even probably until the beginning of this century, it was a pure R&D phenomenon. The short history, it formally began with one paper of McCullough and Pitt about neurons, computer neurons, published in 1943. But the theoretical, the fundamental basis was written, in fact, in 1950 by Turing. And the official birth of theoretical AI is at the workshop at Dartmouth College in New Hampshire in summer of 1956. Then the name artificial intelligence had been defined. It's a long story. What I would assume that you remember that it's not AI, it's not something that began in 2012 as most of the LLM and Gen AI gurus claim, which is deeply wrong and arrogant. AI began much, much earlier. Let's assume that it's 1956. Then a different scientific methods, part of which I have shown in previous slides, began to appear. It's not only neural nets or deep neural nets. They're different areas. What happens is that gradually, however, due to these big capabilities of basic AI to, above all, to predict and reason, AI gradually had spread across all sciences because it helped other sciences with these methods that can accelerate their discoveries. And part of this effect is shown in this slide here. It shows the percentage of AI citations in all peer-reviewed publications. As you can see, what is important here is to see that if 25 years ago, less than 1% AI, the role of AI was limited to less than 1% of publications. But 20 years later, it jumped to 4%. It's not the number of publications of AI only. It's all the publications. That it shows the combined impact of AI in all the research areas, all the other research areas. And the most important recognition of the growing impact of AI in science had been done a couple of months ago with the two Nobel Prizes. Physics, given to Hopfield and Jeff Hinton, and to chemistry, given by Baker, Hassabis, and Jumper. In both cases, it was given to key researchers in the AI area, which to me is a breakthrough in the area of science. AI now, it's recognized as something without which scientific discovery, contemporary science, will be very, very inefficient without AI. AI is a component of contemporary science, independent of the type of science. Then the next wave of expansion, which is even more important to most of us, because the previous one relates to, let's say, a couple of thousands people on Earth. But then the expansion, the Big Bang of AI in the economy is a much more important wave. It happened in two phases. First, the tech giants understood that there is a match between their business model and the capabilities of AI. Some giants like Google, Microsoft, Apple, Facebook found it very early. What happened is they did a brain drain from all the universities and where the top AI professors were at that time, and they moved them created their labs and began in a concentrated manner for a very short period of time to generate new algorithms and new infrastructure for the growing field, especially of deep neural nets. And what also happened, to their credit, they shared their algorithms and infrastructure to the rest of the business. And first, the big business in the US, they already began exploring the power of AI before that first phase of the tech. They didn't need the tech giants to do that. But after the tech giants took the lead and created this cheap infrastructure and in some sense absorbed the expensive R&D efforts for themselves, it made the implementation part of AI much cheaper and easier to the big businesses. That's why in a relatively short period of time of 10, 15 years, most of the big businesses in the United States began implementing AI for their business solutions. I doubt that there is any Fortune 500 company in the United States without a implementation group of AI. And here, this mass scale creation of specialists of applied AI in the business is very clearly statistically shown in the statistics that in 2019, almost 2 million employees in the United States are using AI. 184,000 of them are data scientists. That means they are developing AI systems. And to make the story short, the critical mass of AI specialists is from that time in the business. So AI and this is basic AI, is a business category. But then the big wave came. But before that, let me show you the size of this industrial expansion. Here are two slides that confirm the claims of the big industrial expansion of AI, especially in the United States. The top slide shows the size of and the dynamics of the private investment in AI in billions of dollars. For 2024, it's about 150 billions of dollars. As you can see, the pandemics didn't stop it. What is also very important is the lower part, which shows the number of patents that had been granted in thousands in AI. Because why I give both? Because I may say the top part is more related to reality and more related to what we already have. We invest on what we already have. The bottom part is the expectation of future value creation. Behind any patent is the expectation that, in a couple of years, we'll get value from this patent. That means that in both cases, there is a high hope for the role of artificial intelligence. But what happened in November 30th, 2022, with the announcement of ChatGPT, nobody expected. This very, very high and fast penetration of hundreds of millions into AI, the social wave, the wave that gives not only the opportunity of everybody to touch AI, to increase his curiosity, to satisfy her or his curiosity, to help students to write homework, and to give some business opportunities, but also to give to me some idea about the future world with AI. Only Gen AI, only this integration of Gen AI with the masses can give us the conviction that AI will be part of our life, that AI is something inevitable in our future. And only to show you the hectic dynamics of what's going on with the dynamics in the last 5 years, what's happening. As you can see, for some, almost nobody talked about the current key topics 2 years ago. Even 1 year ago, some of the key topics, especially of agentic workflows, AI agents, nobody talked about this. This is now a science, key development, and engineering. Everybody is in the kitchen. There is no clear theoretical basis of this, which on the one hand is very exciting that you are in the kitchen. On the other hand, it makes everything unpredictable and difficult, especially difficult for the business, difficult to leverage. Or we are living in a very, very hectic, dynamic world. That raises the other key issue. Where is AI going? Because of Gen AI, because of the masses it gave to be introduced and used Gen AI, there are a gazillion opinions. And as I mentioned many times in all my presentations, now AI became a social phenomenon. 25 years ago, it was pure R&D related to computer science. 10 years ago, it became a key driver of the digital economy, especially of the United States. It became an economic phenomenon. Now it is a social phenomenon with tremendous volumes, impacts, and difficulties to analyze. So, what are the topics I'll discuss here? I'll discuss first, to answer the question, what is AI relative to human intelligence? What is the reality? Will it become smarter than us and take our jobs? What's going on now? And based on this, as we will see, tremendous, I call it ideological division. We can go in two key directions. I call it brute force scenario and science first scenario. And at the end, we'll shortly discuss this big mess called artificial general intelligence, and even recently a bigger mess called superintelligence. But let's begin with answering the question. Is the easier topic from all of this, all of the rest in this section of the lecture, a comparison between human intelligence and artificial intelligence. And here is the trap. How to compare? Even, as you know, using some numeric methods to quantify our intelligence, it's a very debatable issue. All the metrics they have their pluses and minuses. And here, any of the large language models have various ranges of tests which can quantify selected cognitive categories. And here I give the dynamics of these categories. Usually there is a human baseline. And now, I'll be very clear, because it's very clear to explain with the first one, the category of image classification. There is a standard test, called ImageNet, which includes 1,000 types of different images, animals, cars, food, etc., and 1 million records. Based on this 1,000, and what is calculated is the error of the classification error. The average error of humans is about 6%, between 6 and 7%, which in this baseline is put as 100%. In 2015, as you can see, before that, the computers had a worse performance, worse than 100%. As we know, here was the big breakthrough that the group of Jeff Hinton in Toronto made with their so-called AlexNet, which dropped the error from 25% to 16%, and that's how they gave the confirmation that we can use deep neural nets with such type of architectures to make a better diagnostic, better classification than humans. And a couple of years later, in 2015, after that, the computers, the deep neural networks, can classify more accurately than humans. This is, and this first category is very clear to explain and very, there are no debates on that. However, for all of the, but this is also, what do we mean by average human? What do we mean by test? The real life is not test. You can find that in a single, for example, to my knowledge, Einstein was not the perfect student. He didn't pass the tests at the university with very high marks. He was, nobody could predict that the future genius will appear as a result of these tests. Tests, to me, it's not the best way to qualify anything in the area of intelligence except to have some easy metric to compare something, nothing more. And based on these specific tests, you can see that one after the other, some cognitive categories, for example, medium level reading comprehension was crossed sometimes in 2018, 2019. Then the visual reasoning about 2021, but still some three others, visual common sense reasoning, multitask language, or competition level math, we are still on the border. So, to conclude that AI, especially Gen AI, which is at the basis of this type of comparison, are deliver much better performance with the higher complexity of the models. That, however, gives to me a wrong high hopes for building something which is smarter than us. First, there are questions about the type of test. Is this the best way to validate intelligence? But then it is the basis and this hope that we can deliver better models without research, only by increasing the computational capacity, led to a very dangerous division of AI. And here this division, I call it ideological or political, you name it. I try to illustrate in this slide, maybe the most important slide in this lecture. What I have in mind. There is one law called scaling law, which is very valid for large language models and which is clearly illustrated on the right part section of these slides, which says that the more parameters we trained a large language models, we, as a result of this higher parametric training, we have lower errors. We have more accurate models. And here the illustration is given by 4 models from 7 billion to 65 billion parameters. And it is very clearly that the error here of the red curve is smaller than the other models which are with less parameters. It's called the scaling LLM law. So the elementary conclusion is that in order to create better models, more accurate models, models that can answer our questions more accurately, we need to train them with more parameters. That means also that we need more data, and above all, we need more computational power. That's great, with that exception that means we need more energy, we need more money, etc. But what it doesn't tell explicitly is that this gain in accuracy is not based on better understanding what's going on in the model. We are increasing the complexity of the model. That's why I put here an icon of a large language models, simply to send the message. It's a complex structure. Here you have, I don't know if it's illustrated with 20 parameters, but take and look at it as a trillion of parameters. And we don't know how this structure is organized and why we have this answer or that answer. Or, in some sense, it is the behavior is unpredictable. That's why what I use this analogy with a black hole. Initially, and everybody is talking about the black boxes. These are super black boxes. Even to me, I made a step more further that to me it's an informational black hole. We throw more and more data, and the mass, the super mass of these trillion parameters simply, hide the relationships there. We don't know what's inside. I call it the non-structural AI. The advantage of this approach, it's relatively cheap, it's fast. We can develop more models with more parameters now. What we need is more money. Yeah, there are some little obstacles. For example, we began to ask the question, okay, but we cannot, the sources of data are less and less. We don't have exponentially growing sources of data that can help us to make the training much more effective. We don't have a source of jump for intelligence based on data, etc. And it can, uh, in fact, create gazillion new models, and that's why it is the engine of the future expansion of AI based on non-structural models. That's why are these two big initiatives of Stargate of at least $500 billion are committed for the next couple of years to build a bunch of black holes on this approach. Sam Altman, the head of OpenAI, and of course Nadella and a lot of others are leaders in this field. I call it the financial field. Even I try not to use to put business behind it. It's mostly the team with the idea of fast results. It's, the ideology, the technical part of the ideology is hidden with the objective of artificial general intelligence. AGI is the key objective. But in fact, the real objective is the exponential profit based on this technology, which in fact doesn't require, and nobody is talking about deep R&D. Nobody is talking to solve and the real danger of lack of understanding with this approach. On the opposite side, which I call it structural approach, is the idea, mostly driven by Jan LeCun, that in the same way as nature, as evolution has shown that biological brains are structured, artificial intelligence has to be structured. And his key idea is that we cannot have AI based only on language, based on LLMs. We need to have a world model in order to act intelligently. So these are these two camps. The problem with the structured approach, which I'm fully behind, is that it requires R&D. It is slow. Nobody knows. I'll show you in a minute some first results, but it can take years. It can take maybe decades. It's a fundamental issue, for God's sake. It cannot be solved in months or naively, as even we will see a lot of people think that it's a question of 2-3 years to get the mythical AGI. So, and let me make a comparison between these two approaches to make the story very, very clear. So, the first approach, we also call it brute force scenario. And we had a discussion, we had a podcast based on this as well. You can watch it with some discussions there. But what is typical for this approach is the brute force. The more we invest, here, for example, OpenAI and Microsoft has this Stargate with $500 billion investment. The other key player here, Elon Musk with XAI, here is the his idea about 1 million GPU Colossus supercomputer, the same story, the same mindset. And I'll give you a clear example of the philosophical, of the deep mindset difference between the two approaches. The issue of weather forecasting is very important. I live in Florida. Here the issue of hurricanes is critical, and the forecast of hurricanes trajectory is a question of business survival for some areas in the state. How we can do it? One way, as we do it in years, is by using physical models of the atmosphere. And I'll show you in a minute how we did it. However, there is a brute force approach. We don't need to understand the laws of nature. What we need to do is to do a pattern matching of if we have data for years, and here, we have training data for 35 years from 1979 to 2017 of more than 1,000 places globally with 227 variables per place, surface, atmospheric pressure, whatever. And we train this monstrous model with 36.7 million parameters. After that, after the model is trained, we simply take this 227 current parameters and we forecast. We don't need supercomputers. And here I gave a forecast. I did it on Sunday, June 22nd, 2025, for, let's say, for wind and atmospheric pressure for Central Europe. What is the first principles-driven weather forecast? Exactly the opposite mindset. Is based on the first in the direction of more and more understanding of the phenomenon, taking into account that we have the atmosphere, we have the surface, Earth's surface. We have different type of models, which are, by the way, very complex. Usually for this first principles driven weather forecast, we're using supercomputers. And you can see here the difference. In order to move ahead, we go to the direction of more and more understanding, and in fact, it is a fundamental understanding. It is based on first principles laws. If we think that our knowledge ahead, our science ahead, will go in the direction of pattern matching, more and more data, more and more combinations with the data, with the reinforcement learning, and no understanding, I personally think will be dead. But that's the road that the unstructured approach is offering to us. I'm fully behind the structured approach, but where it's going, what's the situation? It doesn't have this immediate success stories as ChatGPT and all the other type of multimedia type of models, which are appearing almost daily. But there are some successes in training. Above all, in training, what is it? The basis is training not in details, training not in pixels, for example. Uh, you don't need to train a tree with all the pixels of the tree, but we need to define the concept of a tree. That's the difficult part. That's the abstract part. And to me, the real heavy type of intelligence goes through layers of abstraction, which is absent in the current unstructured model. But what is also important is that there are some, at least some rudimentary experiments to show the importance of structured type of even language models. And here is this study about language, logic, social, and oral type of model architecture, which significantly improved the understanding of the responses of the prompts. To me, this is the direction we need to go. But we reach the point about the directions. And here is another big discussion. Even I'm not worried to use the term mess. And here is one original vision about before ChatGPT, where I think was very clear. We have now the so-called narrow artificial narrow intelligence, which AI can perform, even as we can see, even can overpass humans in performance in several different areas. But there is no, it cannot do everything that a human can do. Then is this next layer, next objective of the artificial general intelligence. And here we'll see in the next slide, when there are a lot of discussion what we mean by this. Is it in all cognitive? Is it in more cognitive? Frankly speaking, it's a mess. What is important is that it puts all jobs at risk. And the final stage is the so-called superintelligence. And about this division and about the issue of superintelligence, the critical role was one book published by a researcher called Bostrom about 10 years ago on this topic. It raised the issue. It became a very hot book at the time, and it raised the issue that it can be more powerful than than humanity, and it could put humanity at risk. Number one. And number two, he had the idea, which is amplified recently more and more, that this period between AGI and superintelligence will be very short. Even what I see is the change of this phraseology is that some people think that we can now jump, that in fact they make an equal sign between AGI and superintelligence. But let's now make a step back and try to at least converge and to understand better what do we mean by general intelligence, by AGI. And here I give three definitions. One, the most popular Wikipedia definition, where I can emphasize on that AI would match or surpass human capabilities across virtually all cognitive tasks. Remember, all cognitive tasks. Then is a bunch of criteria which academics define, which are much more difficult to accomplish. For example, to learn new tasks, to be economically viable, etc. And the key driver of this camp, Altman, his definition, is that it can tackle increasingly complex problems at human level in many fields. As you can see, it's very, very fuzzy. And he was very fair in one of his gazillion interviews answering the same question. He said, okay, well, AGI will come, one will come and will give a definition where it's in some sense based to our understanding. So, and here is the next question. What the gurus predict about AGI? Everybody of the gurus predict what is his individual vision about this, which is very fuzzy. As you can see here, there is one, some of these guys, including Sam Altman, he's thinking even that, okay, it will be a question of a year or two. It may be tomorrow because the earliest assessment is even 25. The only person who has a longer expectation for this is Jeff Hinton. But overall, the majority of the guys have the belief that it could be something within the next 5 years, which I think it's having in mind all the difficult issues and the problems it creates is very questionable. And about this, at the end of this lecture, I have one of the key enigma to me. Imagine that we'll accomplish AGI. What? And AGI will surpass human capabilities. And here, across virtually all cognitive tasks, I'm quoting the Wikipedia definition of this. Then I have the simple question, how? How we'll do it? We have 8 different types of intelligences. What will be the final result of virtually all cognitive tasks? What will have an average between Einstein and Darwin, Ronaldo, Mozart, Brad Pitt, Freud, Leonardo, and Shakespeare? What will be? Or all the people will have, somebody will will be a blend of everybody at the peak. So there are a lot of fundamental questions here. And I strongly believe that we're not very close to that point, but in going toward that point, we need to put a lot of efforts on research. What we need a common sense path to more powerful and secure AI. As my philosophy in finishing this lecture is that the best way to predict the future is to shape it. But in order to shape it, you must control it. And in order to control it, you should understand it. So there is only one way, sure, confident way to move ahead, to increase the research efforts to understand AI. AI should be our friend, we understand. It must not be a black hole, which could surprise us very unpleasantly at any moment. This is the way I think AI should go.